Okay, so when we talk about this unit, we've already done this talk that when you're doing any kind of putting together two functions, your domain can only be where they both exist. Okay, so where they both exist. So let's talk about restricting domains. When we've studied some things, we've studied polynomials. There's no restrictions on those domains, right? When we studied radicals, there's restrictions on radical domains, right? Because we can't square root negatives, so that restricts where we are. So here's some examples from a number to infinity or negative infinity to a number. Also, we've studied rationals, and those have restricted domains, okay, because the bottom can't be 0. So if I look at the bottom, I can't be +1 or -1 on my domain, okay? So something to consider. Let's just flip and talk about these words. So simplify, you're going to see this word. So if I say simplify, what does this mean? It means to multiply it, FOIL, and collect. That's what simplify means. Okay? We need to understand that factoring and solving something is actually completely opposite of simplifying something. Okay? I always get somebody who tries to factor, and I'm asking you to simplify. That's not the process. That's the opposite. Okay, if I have a rational function and here simplify, what does that mean? It means cancel by reducing, and so you're going to factor, cancel, reduce. Okay? And at the bottom here, can we just do a quick recap of how to graph stuff? So we've talked about quadratics in grade 11. I've never seen a B transformation in a quadratic, by the way, so that's why I didn't put it in there. A, B, C, D, but I've never seen a B. Okay, so we know the general idea of a quadratic. How do we know where to put the vertex? Well, you're going to move it according to the C and the D, right? Then you move the vertex. Okay, and how do you go about finding other coordinates? Okay, we square the pattern. We go over 1, over 2, up 4, except for vertically stretch. We times the A. Okay, does that make sense? Square root function is reversing that, because squaring and square rooting are complete opposite math processes. Sorry, I should have done a plus C there before. Okay, so this is a radical. So quadratic is squaring, radical is square rooting. Okay, I'm just giving you a very quick snapshot here. So that's what a radical looks like. So how do we know where to start from? You're going to be looking for C's and D's stuff, right? Moving left, right, up, down. And then how do I know how to make more coordinates? We do 1, 1, 4, 2, 9, 3 as a pattern to a radical, opposite of squaring, because now we're square rooting. And what do? We might have to divide this by B, and what do we do over here? These are X moves, so we can divide them by B, and these are Y moves, so we can times by A, right? Okay? So those are some background things that you might have to just randomly graph in this unit, and that's because it's prior knowledge that you should know. Okay. Do you guys know how to graph lines? Do I have to go through that? What if you ever run into a line? Do you know how to graph a line? From grade 10? Maybe I should do that because that's grade 10. mx plus b, remember that?
Oh, how could I forget?
How could you forget, hey? So this is your y-intercept, right? And then m is your slope. And then on a line, what do you do with slope? You go a staircase, you rise, and then you run. Rise and then run. Okay, and then that makes you get some points. Okay, all that's prior knowledge, so just to refresh your brain with that. Okay, so let's check out. Today we're going to put functions together. Okay, so question 1a here. It says figure out what f of x plus g of x would be. Okay, so I'm going to go f of x plus g of x equals, okay, so f of x is x squared plus 3x plus g of x okay, when I add, does anything change about the bracket situation? No. So I can just really forget that the brackets are there. So simplify means, can I collect anything? Yeah. So my final answer would be f of x plus g of x equals x squared plus 4x plus 7. And then it's done. Remember, don't factor it. Factoring is not simplifying something. Done. Okay? All right. Figure out what h of x minus f of x would be. Sorry, what am I looking at? 4x, because this one had 3 x's in it, and I'm adding one more x. Is it good? Yeah, okay. Okay, so h of x, what is that? X plus 1 minus the f of x. Okay, on this first item, h of x, the brackets I wrote, are they important? No. They're not important. It's really just that. Minus this function, are the brackets important? Yes. Okay, when you minus a family, guess what? The minus has to apply to the whole family. So this is negative x squared and negative 3x. So you minus minus. Okay? So that's important. Okay? So really, if you're just adding things together, really you don't have to think about any brackety kind of idea, but subtracting that. Okay, so final answer is negative x squared. I like to write the boss first. X subtract 3x together. And you have to always remember to give me that title at the start. Okay, so that's again what simplify means: distribute, collect. Okay, this one says f of x times g of x. I'm going to do my rough work and then we'll write the equals part in the final answer here. So I have to do this function times this function. Okay, what kind of process would you do when you start the simplification? FOIL. You would do a FOIL. So x cubed plus 7x squared okay, so you saw what I did. I FOILed. And what else in the simplification after you distribute? Is there anything to collect? Okay, FOILed, collected. Okay, D says to divide the f function by the g function. Okay, so if you wanted to simplify this, you could factor and reduce. Okay? There is something that factors. You could GCF here, right? X bracket x plus 3. You see it? Is that going to get you any cancellations though? No. So I don't even need to do that. State the domain. What's the problem about x's? Where are we restricted on a number? What's the problem with division? Can't be 0 on the bottom, so what's the bad number? -7. So x can be any real number except x is not allowed to be -7. So that's how you can write the domain. And this is a new one. What does evaluate f divided by g of 1? What does this mean to you when you see that? Plug in 1 for x. That's all you're doing. Okay? So we've seen a lot of stuff in the past where it's like f of 5. It just means plug in 5. Okay, number 2 down here. Was this good? I got a half. Is everybody else same thing? Okay, guess what? No calculator, right? Everybody did that? Okay, simplify. And this time it says h of x equals the division. So you can call this h of x. H of x is the division of this over this. Okay, so we are going to simplify this. So I can do a factor and a cancel. Okay, domain and range. Let's talk. Domain. You got to look at the original. Is there anything bad about this fraction? X values. -2. You can be anything except -2. Okay? Range. Do you remember the rule for range? It's all about the degrees. Do you remember this one?
If they're equal, it's top divided by bottom. The bottom's bigger.
Yeah.
I think it's 1,
0. Yeah.
0.
Yeah.
Then if the top is bigger, then it's 1, right?
No, then it's nothing.
Then it's
No.
not.
Okay, so the degree is bigger on the top. So if your number gets, that means your number gets bigger. Does that make any difference? No. So y can be anything. Okay, if the degrees are the same, your asymptote is some number, right? Coefficient division. And if your degree bottom is bigger, then 0. Okay, let's quickly graph this. I want to see what you know. Okay, what is this shape? What is that shape? When you just have an X in here.
That's a line.
It's a line. What do you know? 2 things. -2 is your y-intercept. And your slope is, what number is in front? 1. How do you do a staircase of 1 step? 1 step, 1 step. Okay. But, do you remember what we had here? X is not allowed to be at -2. What do you have to draw on this graph? Do you remember what happened when there was a cancel? A hole. Whoa, my line is funky. So you should know all those things. Hey, how do I draw a line? What did it mean to cancel factors? That meant there was a hole at -2. Okay, sorry, this is just a super rough sketch, but you guys would have more details, right?
Yeah, the range can be right.
Oh, and yes, thank you. Y cannot be at the hole. We have to skip over the hole now. So where is that hole? -2 comma, what's here? -2 comma, -4. Okay, question 3 I'm going to skip. Is that okay? We did one similar. We're timesing, so those things would just get foiled and collected, okay? Good? Skip. 4 I want to go over. I need you to simplify this plus this, and it calls it y equals. The f function, which is this, plus the g function. Okay, now I gave you this one on purpose to test you, and you're going to do this by yourself. I want you to figure out what that squared is. See if you can get it right. I'm going to guess 25% of you are going to get this one wrong. Square that. Okay, did you get x squared minus 6x minus 6x plus 36 when you squared it? Did you remember to do the OI parts? Okay, it's not square this thing and this thing. It's square, which is a x minus 6, x minus 6 FOIL, right? Okay, if you got that wrong, you better star that because we've talked about that idea many times. And then I can't forget to plus 10 here because it told me to. Okay, Here and here, that's where I lose people. Okay, and I think this is the last operation question. You are going to now make up two functions that would add to that. So now you're working backwards. Can you make up anything that makes an addition of that? There's a million possibilities here. You could do anything. I don't know. Yours might be different. So many possibilities. Just making sure if you add them together, they get you there. Okay? Okay, now what you're doing here is you're thinking about two functions that would multiply to that. Can you think of two things that would multiply to that? Okay, there's not very many options here, like the adding, you could do anything really. But this times this, would that multiply to that trinomial? Yes. Okay. I'm going to show you something, but I'm not going to accept it on the test because this is more challenging. Technically, on an exam, I could mark this correct if one of the functions was this and one of the functions was that.
Hey, that's what I
Is that what you wrote down?
Yeah.
Smarty pants. Okay,
Why make things harder on yourself?
that is technically correct.
Technically correct, but you probably still wouldn't get a very good.
I'm not going to give it to you on the test. I'm not going to.
Okay, what if instead of a 1 I did a 2?
Well, this times 2 would make 2x squared minus.
Oh, I have to change
That's what I
something.
did for.
Oh, did you do like a half x squared?
Now at the top I did x squared minus 2x minus 16.